Hi, and welcome to episode 10 of Johnny Does .NET. My name is Johnny Hooibergs, and in this series of videos, I will talk about my favorite programming platform, .NET. In this episode, I will build on top of the already talked about topics for ASP.NET, but I'm going to talk about web technologies that is not going to be used by end users, but it's going to be used by our software components interacting with each other. So our software components will be able to talk to each other via the internet or via a network. And for this, we are going to use ASP.NET Web API and gRPC. So again, we are going to use Visual Studio to create these web applications that we can use to communicate between our application components. So we're going to create a new project and we're going to try to find these web APIs or gRPC templates. So just like our web applications from previous episodes, we can search for ASP.NET because ASP.NET is the technology for the .NET platform to create dynamic web applications. I already discussed most of these templates in previous episodes. I, for example, skipped the Web API because this is the one that we are going to use today. But before I'm going to do that, I'm going to show you the ASP.NET empty template. ASP.NET, again, the technology to create web applications, has an empty template that is not really empty, but it's almost empty. So we're going to start with this one. Very quickly going to create this with all the default settings. And we're going to wait for Visual Studio to load this project for me. There we go. So again, when using web technology, we can create applications that have a client-side facing web application. So a client or a customer or a user can use your web application by using the user interface and this way interacting with all the data that you want to have interaction with or want to provide interaction with. But sometimes we want to communicate in between our services or in between our application components. So we need some kind of technology that is able to send data from one service to the other or to have one service request some data from another service. And ASP.NET can also help us with this. Now, if we look at this empty ASP.NET web application, you can see that we only have that program.cs file. So we only have that application startup and configuration piece. And actually, I said it was empty. It's not empty, but it's almost empty. There's only 4 lines of code here. And we can see the same thing from before. We can see that web application builder. But what we can also see is this piece of code right here. It's the map get method. And the map get method will actually provide us with a description that says, okay, when somebody goes to the root URL for my web application, so just slash means the root URL for my web application, I'm going to implement a handler that is going to return the literal text hello world to that user. And then I'm going to run my application. So if I test this application, if I run it in my browser, you will see that we will get the text hello world back as a response. And the reason for this is because the HTTP protocol, the one that is being used by your browser, is just a text-based request and response pipeline. So actually, when we make a website or a web page, it's using HTML, and HTML is just text. So a server is sending a piece of text to the client. In this case, the browser is my client, and the browser will interpret that piece of HTML and it will show it as best as it can. We are not sending HTML, we are just sending text, hello world. So the browser is also trying its best to show us that data. So hello world is that data, and it's exactly what we see. And this is actually all we need to create the possibility of application components interacting with each other through a network like the internet, for example. If you have one service or one application component that has an endpoint that returns some text, we can have another application component that uses that URL to retrieve that piece of text. And this way we can communicate in between different application components. Of course, this is only one way of doing it. I can, for example, have a second endpoint with a unique URL, like for example, weather, not weather, but weather. And I can return, for example, that it's 22 degrees Celsius. Now, if I use this endpoint, of course, you will all know what will happen. I'm not going to go to the root endpoint. I'm going to the /weather endpoint, and it will return 22 degrees Celsius to me. Very simple concept here. But of course, the 22 degrees is hard-coded by me, but you can get this temperature from somewhere else, from a database or from an external service, or wherever you want it to come from. But this is, again, still text. I'm just sending text to the client as a response. I can do more complicated things. I can, for example, create an object, like a public record person that has a name and has a first name and has a, let's say, age. And then I can create a new endpoint that returns my personal data, and it will return it as an object and not as a piece of text. So I can return a person with my name and first name and my age. Now, if I run this application and I go to I navigate to the me endpoint, I will get not a piece of text, but I will get an object. But what will that object look like? It will look like something like this. So basically, ASP.NET, it sees that we are trying to return an object instead of text, but the HTTP protocol is based on text. So it will serialize this data into something that is text-based. And it is using, by default, JSON to do that. So JSON is short for JavaScript object notation. So it's some kind of technology that is converting objects to text by using the JavaScript object notation format. It's a format that's being used in JavaScript for many years, but now it's like you can use it everywhere from all different kinds of technologies. It is available for you in .NET, but also in Java and almost all other programming platforms and programming languages that you can think of. So it's a very easy format, and you can also immediately see how it works. We have one object, which is delimited by the curly brace open and the curly brace closed. And then we have a number of properties, which are named in between these quotes. And then we have a colon to split off the name of the property with the value of the property. And then we have commas to separate all the different properties from each other. So we have the property name, which has the value Hooibergs. We have then a comma for the next property. Then we have the first name, which is Johnny, comma, and then the age, which is 37. You can also see that Hooibergs and Johnny are texts or strings, so they have quotes also. But then you can see that the age is an integer, so it's or a byte. Doesn't really matter in JSON. It's a number, so it's 37 without the quotes because it's a number and not a piece of text. So very cool. Again, because now we are transferring text, the browser can also show me this text, and I can see that we are using JSON for these kinds of communications. Now, again, very simple technology. You can create as many endpoints as you want. Now I have 3, but if you want to return all kinds of data, that data will automatically be converted into or serialized into JSON. And then the other side of the communication channel, where you have some kind of client application, can do the same thing, but the other way around. It can take the JSON and then deserialize it back into an original object, so it can use that object to do all kinds of things with that. So this is the empty ASP.NET application. So you have all the flexibility to do whatever you want. You can create endpoints for service to service or component to component communication by just doing it like this. Or you can even return HTML files like this. You can have different endpoints that return different HTML files to actually create a web application that uses web pages, for example, instead of doing it with Blazor or with Razor pages or whatever. So you have all of the flexibility. And I've just seen that I typed my own name wrong. So Never mind. Now, let's go back to creating a new project. I talked to you about WebAPI, ASP.NET WebAPI. And this actually was the original template that we can use to create these, what we call APIs. And these are APIs, or application programming interfaces, where we can have multiple services talk to each other using an API, but the API is hosted on the web, on the internet, or on some kind of network, and we can use that network connection to send data from one service to another. If I'm creating a web application, we will see the same kind of thing that I just showed you with the empty ASP.NET application. We can create endpoints, but we are creating endpoints using controllers. Controllers, like we already know from MVC, ASP.NET MVC. So ASP.NET MVC was creating dynamic web applications using multiple web pages, and we were able to use the model view controller methodology. So we have models, we have views, and we have controllers. So for APIs, we are going to use controllers and models only, no views, because there is no user interaction necessary. There is no user interface. We only have the services or the endpoints. So we're not going to use the views. We're only going to use the controllers and the models. So when you do this, you get a more structured way of doing the same thing. If you look at the program.cs file, you can see that now indeed we are using controllers. We are adding controllers to our application configuration. And in the folder controllers, we have a single demo controller, which has the attribute API controller and some route definition with one single endpoint that contains a little bit more code than we've seen beforehand. This is a get or a map get from before, but now it's inside of this controller. And the reason we would use controllers is to create a more nice structure within our application. In the previous example, I showed you 3 endpoints. Maybe if you have 5 or 10 endpoints, it is still a nice way of very minimalistically creating those endpoints. But if you have 100 or even thousands of endpoints within the same application, and it exists, I already worked on some of those in my professional life, then it gets really painful to put all of those thousands of endpoints within that same program.cs file. So in that case, you can use controllers, and you can functionally split up all of your endpoints into their proper controllers. Now, in this case, we're doing weather forecast. So I have a weather forecast controller. And when I go to the get endpoint for that weather forecast controller, I'm just returning 5 random weather forecasts. So if I launch this application, you will see that by visiting the weather forecast URL, so weather forecast URL, I get a piece of JSON returned that describes to me these 5 random weather forecasts. And again, you can see the same concept. Each object has the curly braces as the delimiter, but now we have actually a list of 5 of these objects, which is an array of 5. So you can also see the square brackets. So the square brackets, they delimit a list or an array, and within that array we have multiple objects that are using the curly braces, and they are separated by using the commas. And again, you can see these properties: temperature, summary, date, and so on. So very easy. Now, maybe you already seen, but I something was appearing, and I did not talk about that, which is Swagger. So if you are creating a web API instead of the empty ASP.NET application, by default you can have OpenAPI support. And OpenAPI support is actually a technology that automatically generates a user interface on top of your web API that shows you a list of all of your endpoints that you have created in code. And with these endpoints, you can even try them out. So I can try it out, click execute, and the endpoint will be executed in the background, and I can see the result within my browser in a nice way. So if I scroll down, I can see the response. I can see the same JSON data, but it's being formatted a little bit more nicely. So I can indeed see I have the date, the temperature, and the summary for each of the 5 random objects who live inside of this array. To enable this automatic generation of of this page, the only thing you really need to do, if it's not done automatically for you, is add the Endpoint API Explorer in your application configuration, the Swagger Gen, and then the Swagger UI. The Swagger UI is being used to generate that HTML user interface that I can click around in to view all of my endpoints. So that's it. That's OpenAPI or Swagger. So very cool. It's not really necessary for your users because you will not have any users because you're creating an application to communicate in between services via a network, but it is a handy tool for you as a developer. If you as a developer are creating a web API, by just launching your web API, you can use your browser to look at all of your endpoints and to test all of your endpoints. And not only for you, but also for the people you are working with. If you have an external party that wants to use your API endpoints, you can provide them with access to that Swagger page, and they can actually learn, okay, these are all the endpoints that are available to me. This is what the data looks like, so I can interpret that data and I can do whatever I want with that data. There are actually many organizations out there that provide these kinds of APIs that we as a developer can use to get some data, get some necessary data. One example of for example, is Open Weather Map, which is a service that you can use as a developer to get the current weather and the weather forecasts for all places around the world. It is free, or you can pay for it if you want to have more premium access or more requests per second, for example. But it's the same concept. They will provide endpoints that you can call from your applications to get the current weather, but also the future weather forecasts. And they also provide an interface for you, so you can test all of the endpoints. You can learn from that, you know how to use them, and then you can implement them in your technology of choice. Open Weather is one of the many that is available out there. I know that today many countries will also provide important data as an open API, as a service that you can use to get that data and use that data for some reason. Okay. I already talked about controllers, so if I want to add a new endpoint that is functionally different from weather forecasts, I can just very easily add a new controller. So I can do, for example, the person data, my personal data, which was the me endpoint. So let's add a me controller and just do some copy paste from the already existing controller. I need the API controller attribute and the route attribute on top of my controller. I need the controller base class for my controller, and I need the actual HTTP endpoint for my controller. So this is going to be named getMe. It will not return an IEnumerable of weather forecast, so no array of forecasts. No, it's going to return a person object. Of course, I need to create this person object, so public record person, string name, string first name, byte age, like that. And instead of returning 5 random weather forecasts, I'm just going to return me. So new person with my name and my first name and my age. So this is basically all you need to do to return some data. So you create a new controller, you mark it as an API controller, and by marking it as an API controller, it will automatically be recognized and it will be included in your web application endpoints. The route specifies that the URL that needs to be entered to hit this endpoint will automatically be named after the name of your controller. So it's the me controller, so it will be root. It will be the route of root/me. The method is called getMe, and then it returns a new person. Also a cool thing from this OpenAPI and Swagger implementation that we added to our application configuration here is that it will automatically recognize all of your endpoints and it will include them in the user interface. So if I run this application, of course, I can just visit the /me endpoint and I will get returned that endpoint. That is how you should use it from another application component. So that application component visits this URL and it will get returned this piece of data. Very simple. But as a developer, you can use Swagger to do your testing, and you can see that now the me endpoint is included. So I can open it up, I can try it out, click execute, and I can indeed see that my data, my personal data, is now returned successfully, and it's formatted a little bit more nicely. So very cool stuff here. So I already talked about two different ways of creating your service-to-service communication using ASP.NET APIs. So you have the empty ASP.NET application where you have all of the flexibility to do it the way you want it. And you have the Web API version where you have controllers. You can have multiple endpoints. You can categorize them using different controllers. And you can have more fine-grained control in how you write your code inside of these controllers, inside of these HTTP actions. Now, there's one thing that I did not yet show you. You can also create a Web API application and do some kind of combination between the empty one and the Web API one. So if you take Web API as a template, but you disable the use controllers checkbox, you're actually going to use minimal APIs. And minimal APIs is the thing that I showed you from the empty ASP.NET application. You're actually you're not using controllers, but you're just creating a list of these map get methods or other methods. You also have the support for that open API. So you don't have to do it manually. You don't have to add it manually. The template will do it for you. You can also disable it right here to disable the open API in Swagger. But I want to enable it, and it will basically create the same kind of demo template with the weather forecasts in a minimal API structure. It's called minimal API because we need a minimal amount of code to do basically the same thing. So it's a personal preference here. If I do it like this, I don't have any controllers, but all of my endpoints are now again in my program.cs, and it can contain some more code. So my personal opinion, if you only have a few endpoints, you can do it like this. There's going to be more code in your program.cs, but it's okay because it's only a couple of endpoints. But if you have many, like 10, 20, 30 maybe, or even 100, or especially if you have more than 100, you could maybe put them in separate controllers, or you can try to figure out something in combination of the minimal APIs. But I don't want to have hundreds of lines of code inside of this file only to define all of your API endpoints. But this, of course, is kind of the same thing as the Web API before, or the empty ASP.NET before. We have that map get on the weather forecasts. It returns the same array of 5 random weather forecasts, which uses this object right here. And it uses, again, the Swagger UI and the endpoints API Explorer. So if I run this, the result is the same thing. The result is a web application that can return data if you call the correct endpoint with the Swagger UI that you as a developer can use to test your endpoints. So I click execute and I get the exact same result, or the exact same random result. So for this, if you're using web APIs, you need to make that decision yourself. Are you going to use controller-based APIs or the minimal APIs? Now, this is all good and well. I talked to you about creating these web applications for service-to-service communication within your application. So users are not going to see this. Users are just going to use another client application, but your different application components, they will need to communicate with each other by using a network like the internet. But if you take a very close look to the weather forecast, for example, if we are doing service-to-service communication or computer-to-computer communication, then the data that we are sending, it should not really be readable, or it doesn't have to be readable, because there's no users that are going to read it. If you take a very close look to the data right here, you can see that we are actually repeating a lot of data because we are repeating the names of the properties. We are repeating the date. We are repeating the temperature. We are repeating summary and so on. Why? You can see date, 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 and so on. So it's pretty okay for this because we only have 5 objects. But let's say we have thousands of objects and we want to send thousands of objects from one service to another using this technology. We are sending the names of all of those properties thousands of times, which is basically data that we don't need, or at least we don't need it to be repeated all over again. It's redundant data. So if we are going to think about another protocol of sending data in a binary format, that would actually be very good for us, because now we don't need as much bandwidth, because we don't need to repeat all of that redundant data. So our application will be more performant and cheaper because we don't need to use so much data. So for this, we also have other technologies. The reason WebAPI and HTTP are so popular right now is because, of course, it's very easy to test as a developer, but we can also use it from all technologies. You don't only need to use .NET, you can use all kinds of technologies, all kinds of programming languages. They will all support HTTP with the responses on your requests by using this JSON format, for example. Now, if you're doing binary communication, of course, your programming language needs to support this specific binary communication. And there's actually a new kid on the block, which is called gRPC. So if you search for ASP.NET or if you search for gRPC, you have a template specifically targeting ASP.NET web applications that are using gRPC to communicate from service to service. gRPC is not made by Microsoft. It's just a technology that's already existing, that is now supported within .NET, the .NET platform, which also has its own template in Visual Studio and in the .NET CLI, of course. Now, this looks a little bit different than the Web API. You are creating a gRPC project, and you are basically creating services with endpoints that are called procedures, because RPC stands for Remote Procedure Call. You are calling a procedure remotely from a remote location. So from one application component remotely to another application component. Now, again, the program.cs is very similar. We have a web application builder because we are still building web applications, but now we are configuring to use gRPC. Now, here you can see we are actually also using the map-get endpoint with the handler that will just state to some kind of user that tries to use our application from a browser that communication with gRPC endpoints must be made through a gRPC client. Because we are communicating using a binary protocol, we cannot test from the browser because the browser has no support for this binary protocol. A browser is built for showing us text, maybe HTML-based text or just raw text, doesn't really matter, but gRPC is not a text-based protocol, so gRPC is not supported by your browser. That is why this message is shown by default. If somebody navigates to your web application, it will just show communication with these gRPC endpoints are not available to you. They must be made through a gRPC client. Now, we are also mapping a gRPC service called greeter service. And because gRPC is a binary format, we need to describe what this binary format will look like so that the client and the server can communicate and they both know what the binary format looks like. And in gRPC, this is called a protobuf file. A protobuf file is kind of its own language. It's this descriptive language that you need to use to describe your service. Your service is just like a controller in Web API. You're basically creating one service that bundles one or multiple RPC procedures. In this case, it only has one. And this is called say hello. Now, this say hello method or function or procedure has a request object and it returns a reply object. So you send something with your request, some data, and you get some kind of reply. And sending the data and receiving the data is binary. So it's not using JSON, it's not using text, it's using some kind of binary format. So we need to specify what properties in our objects are available. So here we have a request object which has a string property, and we have a reply object which also has a string property. Now, the properties look kind of similar like C#. We have a string which is text, the name of the property is name, and then we have a weird value equals 1. 1 is not a string. No, actually this is not a value. This is the order in which you are using your properties within this binary format. Because we don't use text, we can't describe what the property is named, and actually we don't need to know what the property is named. If server and client are using the same object to do communication, if they both know what the hello request object looks like, they only need the order of the properties. So if you have multiple properties, for example, like let's say the name, the first name, and the age. Age, of course, is not a string, but it's an int. And these are no .NET properties, these are protobuf properties, so we need type specific for protobuf, so int32, which is a 32-bit integer, and of course you need to specify the order. First the name, then the first name, finally the age. And because you specify the order, the server and the client know how to communicate with each other, because if you just have binaries, ones and zeros, you know that you can just take the first part, which is the name, then the second part, which is the first name, and then the final part, which is the age. Very simple. Of course, there's some way of there's some binary format that will specify where the name stops and where the first name starts, but you only just need one character to do this. You don't need the description of the entire name of your property. So the order here is very important. Now, when you have that protobuf file, of course, you still don't have classes or records in C# for these request and reply objects. You just have the description of the binary format. That is why if you look at your project properties from C#, that you can actually specify on your protobuf file if it needs to generate C# code for you for server, client, or both. So by default, because we are creating our web service, our web application, this will act as a service. We can create a second application, like a console application or a WinForms application, that will act as a client. So it will need that same protobuf file, and it will need to be configured as client. And then it will generate client code that you can use to call from the client to your server. Now, because this one says server, it will generate server code for you, and we can implement the greeter service in C#. So the greeter service is our class that implements from that generated base class greeter base, and this has actually all of the code necessary to make the actual communication. So we don't need to dive deep into how to communicate from a gRPC client to a gRPC server. All of that code will be generated for us. The only thing we need to implement is that say hello method from our proto service. So here it says say hello with the request and the reply. In C# it says say hello with this request, and it returns a hello reply. These objects are being generated for us, so we don't need to create them manually. I can just use them. So the request has a name property, which is a string, and the response or reply has a message property, which I'm going to set as hello space and then the name from the request. So if you send from your client a request object that has your name in it, or my name, Johnny, the reply that will be returned from this server will be hello, Johnny. Very simple, very simple. So this is another technology to do the same thing. We have multiple components, multiple application components. They need to communicate with each other via a network. This still uses HTTP, but it uses a binary data format to send that data. And that data will be more performant because it uses less bandwidth, less data. So very nice for your service-to-service communication. Again, if you really want the flexibility to be able to look at your data or to interpret the data like you want, you can go with WebApi because it's very easy, because it's text-based. But if you really want high-performance service-to-service communication using that binary format, I would suggest you use gRPC. In some kind of later video, I will dive a lot deeper into all of these technologies. gRPC, for example, also has support for streaming data, because right now we are working with a request-response kind of communication. We send a request and we get immediately a response. But gRPC also has support for streaming, where we can have a communication channel open the whole time and we can stream data from client to server, but also from server to client. But I will show you this a little bit later. So again, to recap, WebAPI, gRPC, two technologies that do exactly the same thing, send data in between your application components. One is using HTTP with a text-based request response, and gRPC is using a binary format that is much more performant and where you have a completely different way of writing your code. Up to you which one you like best, or in which specific case you want to use one of those. And with that, we reach the end of another Johnny Does .NET episode. In this episode, I talked about ASP.NET WebAPI and ASP.NET gRPC, templates that are built on technologies that help us to create interaction between our application components. So our application components can interact with each other, can send data to one another using a network connection like the internet. In the next episode, I will talk about worker services. A worker service is an application that we can use to do background work in the background without the need for user interaction. Did you like this episode? Please give me a thumbs up, and if you want to be notified of future episodes, don't forget to subscribe to my channel. I'll see you next week.